Hi, welcome to the last video of this series. In this video we're actually going to tune the PID controller for the temperature control lab. We're going to use the PID Tuner tool from the PIDtuner.com website, and I'm really excited, so let's get to it.
Alright, let's start with the PID tuning. First we're going to look at the default PID tuning because the test PID.py script already has a default PID tuning. So let's look at it and see how it responds. First, let's take a look at the PID function in this script. We can see that the PID function is at the beginning of the script. We have the proportional, integral, and derivative gains here. And we can see that the values right now are 10, 50, and 1. So let's take a look on how these parameters perform. First, I'm gonna modify a little bit the plot that we're gonna see in real time. I'm gonna get rid of the second heater variables, and I'm gonna only display 2 of the plots for the heater 1 input and output. And well, let's save our script and run it. See how the default PID behaves. Run module. We're gonna start seeing our real-time data. Oh, there's an error here. We're missing a dependency. Remember in the first video that we installed some dependencies? Now we're gonna do the same here. We're gonna go to the Windows command line and put pip install scipy, which is the dependency that we're missing. All good. Okay, let's try again. See if it works now. Run module. Okay, all looks good. Let's see. Now on the first plot we see again our temperature 1 measurement in red. We now have the set point in black, and on the second plot we see again in blue our heater input. So we see that the first step goes nicely up and then down, and then on the second set point change we see a little bit of overshoot, but overall this is really good tuning. But the question now is, how did we get to these values? Like, they were already there, so job is done. Yeah, but what happens when I don't have a starting point? Like, what do I do? So let's go back to our PID tuning, PID tuner tool, and copy the values that we get from the last video when we selected first order model. This will give us only PI, so only proportional and integral values. So, well, we're gonna copy the proportional gain and the integral time just as it is that we got from the last video. If you missed it, you can go back and watch that video. Let's see what happens. You know, this is the starting point that the PID tuner tool is giving us. So let's see how this performs against the default tuning that was already on the script. Let's see what happens. Let's experiment. So we again see the first step response, the first set point change. We can see that it's going on the right direction, but we don't really reach the set point. Now we're going down, and the same case, we don't reach the set point when going down. We get the second step up, and yeah, this time we reach, but you know, overall it's a good starting point, but I think we can improve. So let's see what we can do. Let's go try to make a second attempt at PI control. Now let's go back to the PID tuner and make it more aggressive by moving the scale gains slider. Let's round up these values and copy them to the script. It's 10 for the proportional gain and 110 for the integral time. Let's run again and see what happens. Okay, our real-time data again. Really nice from the temperature control lab. Now we can see again, now we are getting closer and faster to the set point, but we still don't reach it the way I would like, at least. But it's better. Like, we made PI tuning more aggressive. Now we have a little bit of overshoot, just like in the default tuning. So let's see how we can improve on this. Let's try maybe with a PID tuning now. So how do we get PID tuning? Let's go back to our PID tuner tool and select the second order model. The second order model is gonna give us some PID tuning now. So now we have derivative time. So let's just make it more aggressive, because we can handle more aggressive tuning from our previous experiences. So let's copy the values directly from the PID tuner to the test PID script and run it and see what happens. Alright, overall looks good. It's going faster to the set point. It actually reaches the set point this time. It's going up and now it's going down. But now we see that something funny, our input is really noisy. And you know, in some applications this might be acceptable as long as the measured value reaches the set point, but in some other applications it doesn't. So even though our PID tuning looks nicer now and even closer than the default tuning, we gotta do something. Let's see what we can do with this noisy input. So one idea and one trick to improve on this is to filter the derivative action. So let's see how we can do this. First, we're gonna touch a little bit our values, make it slightly round them up, slightly more aggressive on the integral action, and also slightly more aggressive on the derivative action. And let's just copy these values to our test PID script, 18, 80, and 13.5. Okay, so now let's implement our filter. So let's go and find some place to put the state of our filter. It's the memory of our filter. Let's call it XF. Start with a value of 0. And we need to pass this variable to the PID function as an input, and also we have to get the state as an output, because this state is going to be changing on each iteration of the PID. So now let's pass it in our PID function, and let's make a variable for the filter pole. It's a variable value of 0.2. It's a variable that should go between 0 and 1. When we give a value of 0, we are only looking at the past values of the filter. When we're giving a value of 1, we're giving more importance to the most recent value. So a value of 0.2 is kind of a trade-off between the most recent value and the older values. You can play with this parameter as well. I just put 0.2 and let's see what happens. So we're going to test this. We're going to change the set point up nicely. We're going to reach our set point. And now notice that the input is less noisy. It's still noisy, but less noisy than before. I look at this and I see, well, this is already acceptable for me. So it depends on your application. Your application might require a filter on the derivative action or not. That's up to you, up to your control requirements. But for me, this already looks pretty good. We don't have an overshoot on the second set point change up, so that's really nice. Okay, let's stop here.
So we learned in this video that PID tuning is really an iterative process. It's really hard to get a starting point for PID tuning, but we saw that the PID tuner tool gives us a good starting point that we can use to iterate and get the desired performance that we want for our control system. I hope you enjoyed this video and see you next time.